Okay, so let C be a category, any category. We're going to define new categories when the inductive or when limits or co-limits of this category don't exist. So we're going to define C pro to be this. This is going to be the category of pro objects of C, and so this is the replacement for limits. And so this is using the old terminology of projective limits, so things with the backwards arrow usually. And then we're going to define another category, C ind, which is the category of ind objects of C. And so this is a replacement for co-limits, for the non-existence of co-limits. And so ind is this old terminology of inductive limits. So in order to give the definitions, I'm going to I need to talk about diagrams real quick. So remind you a little bit about diagrams. And I just want to give some definitions. So definition. So D is a filtered category. Is a let's say filtered category if the following holds. So first, D is not empty. Second, so for every X and Y in the category D, so that there exists a Z and there exists maps X, Y to Z. And the third thing that we're going to require is that there's going to be kind of equalizers. So it says for all F and G parallel. So this means that we have F and G are maps to the same guy here. There exists some H from Y to Z in this category D, such that the following holds. Well, this diagram here, F, G, Y, H, Z, is commutes. So it commutes. So in particular, this is saying that here, F composed with H is equal to H composed with G. Okay, so this is all that this is saying. So that's what a filtered category is. Then we can ask what a co-filtered category is. So this is going to be used. This filtered category is going to be used for the ind objects, and then the co-filtered is going to be for pro objects. So okay, so let me just say what a co-filtered category is. So co-filtered category. Okay, so this is a co-filtered category if these arrows are reversed. So instead of this diagram, so we have it not empty, then here we go like this, and then we're going to have kind of the opposite thing here. So where we flip the arrows. So for every situation like this, there exists a guy which is co-equalizes this thing. Okay, so this is what a co-filtered category is. So this is the opposite. So literally it's the opposite category of a filtered category. Filtered category. Okay, so these are the things. So filtered categories are the things where you do limits and co-limits, and co-filtered categories are where you do or limits. So it's kind of confusing. I guess it's kind of opposite to what you think. And so So co-filtered things are the things where you're going to do projective limits. Okay, so they're kind of the inverse systems here. So like you can go backwards. So this is saying that you can go up and up and up. Okay, so so how do we want to define? Now I want to talk about the definition of this category, this inductive category here, the category of inductive limits in C. So the objects of this category. So these are going to be diagrams here, where D is a small. So small meaning that the Hom sets are sets, filtered category. Okay, so this is where the objects are, and to determine what the morphisms are. So the morphisms. Well, I'm just going to say what they are, and then I'm going to explain how we get this. So the morphisms, so if I have two such diagrams, C, and I take this end, and then I take two diagrams, F and G, and let's say F is from this diagram, and G is from this diagram, E to C. Then this thing here is going to be defined to be equal to, well, you take the limit of over the first diagram, then the co-limit of the second diagram here, like so, and you do C of F, D, G, E. Okay, so this is what the morphisms are. Let me explain how you can get this. Okay, so morphisms, the requirement for morphisms being this way follow from three facts, three properties. The first property is that that there's this functor here, here from this the category of end objects, where you can take an object in this category and associate to the stupid diagram, where you have a single object here, and you take this diagram here. So this is a functor from this stupid category with one object into C. And so what are we going to require about this thing? So the three properties are that this functor is full and faithful. So the functor, let's call this I. So this I is full and faithful. And faithful. 2. So this means that the Hom sets are going to be essentially the same thing. The diagrams okay, so diagrams are limits of themselves. Via so they're actually, I guess, co-limits of themselves. Co-limits of themselves via the inclusion I. The third thing that we require is that so objects are compact, and I'll explain what this means. This just means that that we'll be able to commute the Hom sets on the other side. So it means that essentially that the Hom of this with a co-limit of yi's will be equal to the co-limit of the Homs x yi's. So if you take a co-limit like this, that you can commute these things. Okay, so this is implied by compactness. Okay, so now we have these, and now I can write out what this these things are. So this so again, we have two objects in here, and they're going to be equal to this inductive limit here, and this is going to be the co-limit of these diagrams, like this. So they're both co-limits of here. Okay, so all objects are co-limits in this category, and this is that property that we had. And this thing says that contravariant functors, this contravariant Hom functor will take co-limits or co-limits to limits. So we have the following. Let's see. Okay. Okay, so we have this object here. So this is kind of just a general fact. The next fact that we're going to use is we're going to do analysis on this piece, and we're going to use this compactness. And then we have a co-limit of E and E of and G of E. And now we're just going to use the faithfulness. Okay, so this is how we determine the morphisms in this the ind category. Okay, so for pro objects, we're going to do something similar. So for this category C pro, the objects. So these are going to be diagrams here, where D is a small co-filtered category, and we talked about co-filtered categories. These are the opposite of filtered categories, and they're the things where you can talk about projective limits with. So small co-filtered category. And then the morphisms. So we're just going to do the exact opposite thing. Sorry, this is here from FG. And so this is going to be defined to be equal to the limit of the co-limit of this guy here. Okay, so this is the other thing. And so here we're just going to have the same thing. You know, you're going to have properties similar to this one. So we have a full and faithful functor, right? And the functors will now be limits of themselves, and then I guess the objects will have to be co-compact. So we'll do the exact same thing. Okay, so that's all that I wanted to say about this. Thanks.